Hi, in this video I'm going to talk about how we can use MATLAB's deep learning toolbox for purposes other than image classification. Specifically, I'm going to show that how we can use the toolbox to train network with numeric features or even time series forecasting. So ideally, we could do them by writing commands in our command window, but I think that Deep Network Designer provides us a nice visual feel, easier, and we can do very back and forth to train our network. So let me just launch it and show how it looks like. So Deep Network Designer is present here within the apps, and once it launches, it gives us several options that we can use some pre-trained networks or just use a blank network. So I'm just going to go to the blank network and show a feature here, which is the second tab. That's the data, and this is the part right now. So far, the other tutorials that are present use this Deep Network Designer for image purposes, but we can use the data, actually specifically the import data store function, which will allow the Deep Network Designer to recognize the data sets which are numerical in nature. So we'll close it for a while and just go back and talk a little bit more about the data stores. So data stores ideally are available in many kinds in MATLAB, but for deep learning, they say that although there are different built-in data stores, however, only some types are just can be used directly as an input. However, that does not restrict us. All of these data stores that can be directly used as an input are image data, but there's also a feature kind of data set that we can, if we can make MATLAB Deep Network Designer understand this, then we have solved the problem. Ideally, what we would like to have is that we would be creating a data store which will give us an output like this. So we will have two columns, a table with two columns. First is the response. Sorry, the second is the response, second column of the output. And the first column can be an array, a cell array having multiple columns. I think this example here, it's actually an image, it's three-dimensional. What we will have is a column vector within this column. So the data stores, different kinds that are available, can be again found here, different formats. For this video, I'll be using the tabular text data store, and to create the tabular text data store, what we need to provide the location of the data set that we are going to use. So to show how to use this tabular text data store, I will be focusing more on this tutorial, this example that has been given, where we use the transmission data set, and we have total 21 variables that are present. The 21st is our response here to the condition, which is a categorical variable, and we have two more actually variables which are categorical in nature. The rest 18 are numeric. So as we just talked about, that the tabular text data store requires the location of our file. So ideally, we can just use this file name and use that to use data store, but I will make some tweaks. I will do some pre-processing, actually just the pre-processing that's been given here, and separately save the training as well as validation data set. So let me jump onto the code here. So these codes have been copy pasted just from the tutorial, and I will post a GitHub link on the video. You can just access this. And after creating actually the let me at least load the data just to show that we have 208 observations and 23 columns. So the two columns have been created are categorical. Two extra columns are the categorical variables. I'll show you that. So we have 18 numeric features, and then two categorical variables with their dummy variables associated. Finally, we have the response, the 23rd column. So what I do next is that I separately create like the training as well as validation and save them as training and validation CSV files. And without much delay, I just want to talk more about using the text data store. So the first command that I use is that I will use this tabular text data store, and to let MATLAB know where our file is for training. So we just copy paste and run it, and we can see that the text data store has been specified, and it has the preview command gives us the first 8 rows, and each row has 23 columns. We can see more of the data store file. So data store does not load the entire data, rather it provides a location of where our original data set is, so that it does not consume RAM while we are working or training the network. So that's a good thing about data stores in general. And however, right now the challenge that we are facing for our problem is that the data store that the designer will recognize will only have 2 columns when we are thinking about single input layers, by the way. But however, here we have 23 columns. So the trick here that we'll be doing is that we are going to transform the data stores, and for that each data store actually has this really nice capability, transform function that is associated with the data stores. And what it does is that it will read the data, apply that transformation function, and give us the output that we desire. And here what we want is that instead of having this 23 columns, we want 2 columns. The first column would be again a 22 column vector. The second column would be our response. For that, what I do is that I wrote this transform function which takes the data store, applies the function which gives us an output where this is the first column, that is on the first 22 columns. We're going to split them. We have 149 rows here, so we're going to just split them, make a transpose so that it becomes a column vector, and just give us an output of 22 cross 1. And the second column is just our response, so that only the 23rd column of our data store. So after using this transform function, we actually create a new data store. Just put a word new here, and let me run it and show you how it looks like. So we can see the output, the preview of this new data store has this 22 column vector as our first column, and then we have our response as our second column. If I open the data store new, so you can see that there is a transformation function that's been applied. It's a function that which we put, but the underlying data set still remains the same. So that's still the same file that we have, the original casing3. So the thing is that it does not, good thing is that it does not create a new data altogether, rather it just specifies a function so that whenever the temporary data are being read, they are immediately transformed through this transform function. And now this format is what the deep network designer can recognize. So before jumping there, I will run the same commands for our validation data set as well. The validation data set output also looks the same. So I now launch the deep network designer, and I'll create the network that's given in the tutorial, but instead in the tutorial we have to like write out each function, each attribute, each property of our problem. Here instead it's fairly fast, so we'll start with a feature input layer, and now we have 22 features. Let's normalize it using the z-scores, followed by a fully connected layer, and let's give it 50 nodes. Then we have a batch normalization layer, a ReLU layer, again a fully connected layer, but now we just have 2 outputs in our response. So let's give it 2 outputs, and finally a softmax layer followed by the classification layer. So I'll quickly connect them, and for neatness, let's just auto-arrange them and analyze if there's any issue with the network. Well, no errors have been given, so our network is good. Going next to the data tab, in the import data, I'll use the import data store function, and here we will have the new training and new validation data stores that we reference to. I'm going to import that, and we can see that we have this the predictors that we created, as well as the response that we have. So again, just going back to the kind of format that we wanted. Here, let's see by one column vector of our predictors, and that's what we got. So coming back on the data network designer, I think we are good to go. Go to the training, and just put out, because we have a very small data set, so I'm going to change our optimizer to Adam. Let's say the batch size is just 16, and I think I can keep the rest as usual. Just close it and start training the network. Okay, so our network trained fairly fast. For this problem, it's a very small data set, and we achieved validation accuracy of close to 95%. And after training the model, I think this is good. So after training the model, we can export the trained network and results, or we can put more effort in even reaching 100% validation accuracy, but that's not the motivation of this video. So instead, what I will do is that I will close the designer and talk quickly about the second problem on the time series forecasting. So I have written a very similar code. This is again copy pasted from the tutorial, but instead that we just save our all training data set, so no validation is associated for this tutorial. So I'd save the all training in the CSV file, and once again just read the data store file that and we can see that we have two variables. Actually, we just have, because it's a time series problem, we just have one predictor and one response, and this is more like a regression problem. Still, I'll just do the transformation for this data store as well, and you can see the transformation functions look similar to the previous one. So running that, we get our transform data store, which is a format that our deep network designer can understand. So we'll create the deep network designer. I will create the network in the deep network designer just to show how this works. We'll start with the blank network, and let's start with the sequence input layer. We just have one feature, we just have one X, and followed by an LSTM layer. Let's give it 200 units, and a fully connected layer. The response will still be just one. We have only one output, and this is more like a regression. The output is continuous, so we have a regression layer. Connect all of them, auto arrange, and then in the analyze. Okay, no errors. This looks good. Data, let's go to the data store, and we're going to give it the new training data set and no validation. So even if it overfits, that's okay. Again, not the concern of this video. So we import the data set, we get a preview, again like an image, but let's go to the training, and I will play some more with the training options so that it gives us somewhat useful results. We'll never So I made some changes here in the training options as given in the tutorial. And then after that, I'm going to close it and let's start training our network. Okay, that was fairly fast. So training is finished. It reached the final iteration, and we can see that the RMSE starts to saturate. Although I recall that in the tutorial it goes further below, but I think that's a good thing about Designer, that we can now go back and make some changes even if our network design or some training options that we want to change and read on it. So instead of writing a code, changing our layer manually, this I believe provides a better, a nice visual way of changing our network and retraining them. And I think through this video, we learned how we can use data sets of different kind in data store function for purposes other than just image classification. So thank you very much for seeing this video.